Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at graphing systems of equations and finding the solutions. Let's go ahead and get started. So we saw in the previous lesson that when we graph a system of equations that contains both a linear equation and a quadratic equation, that we have three different types of solutions. We can have a system with two solutions, where the linear equation and the quadratic equation basically the line and the parabola have 2 points of intersection. We can have a system of one solution in which the line and the parabola have exactly 1 point of intersection. And we can have a system with no solutions in which the line and the parabola have no points of intersection. And the goal for today is going to be using technology like Desmos or a TI-84 graphing calculator to actually visualize this and see where the solutions to the system will be. Me personally, I'm going to be using Desmos. I feel that Desmos is a lot more efficient than the TI-84 graphing calculator. And Desmos is also free. Everyone can have access to it. So that's what I'm going to be using. If you want to use a TI-84 graphing calculator, that's perfectly fine. There's probably some videos on YouTube that you can find for sure that will help you find the points of intersection. Okay. So what we're going to do here is there's going to be 3 practice problems. I've already got them worked out, but I'm going to talk you through how I approach the problems, how I plug them into Desmos, and how I use Desmos to find the solutions. So here's the 3 practice problems. Our first one here is 3y squared plus x minus 12y plus 8 equals 0, and then x minus y equals 3. And what we're going to do here is we're going to plug each of these equations into Desmos. So into line 1, 3y squared plus x minus 12y plus 8 equals 0, into equation line 2, x minus y equals 3. And we can see very quickly from Desmos here that the line and the parabola will never have any points of intersection. So we would say that we have no real solutions. And what I did here on my notes is just, I went ahead and plotted some points that I could see from the graph. Notice in Desmos, if you click on the function, you get these little gray points that show you some of the key features. Like this is showing you the y-intercepts. Those aren't very good points to graph though. But we can see the point 4, 2. And you can also see, if you scroll a little bit out here, you can also see some points at negative 8, 4 and negative 8, 0. So I also put those points here on the graph. Negative 8, 4, negative 8, 0. And then we of course have the vertex 4, 2, which we can see right here. For the linear function, again, I plotted some points that were easy to see here. We can see that we have 3, 0, 0, negative 3, and I went ahead and plotted those. Here's 0, negative 3, here's 3, 0, and then I just went ahead and sketched my line, just so I have a visual image here of our solution. All right, in the second system, we have negative 2 times y minus 4 equals x minus 3 squared. There's our quadratic, so we're going to get a parabola. And then we have y equals x minus 3. There's our linear function. We're going to get a straight line. And we're going to get, this is going to be a system that has 2 solutions. And let's see why that's true. So let's go ahead and hide these graphs. And the 2 new equations are right here. And notice in Desmos, we can see pretty easily that we get a graph, one parabola facing down, and we have a straight line with a positive slope. And if we click on the points where they look to intersect, Desmos is going to show us exactly what those points are. So I clicked on them, I see that it's negative 1, negative 4 is 1 point of intersection, and 5, 2 is another point of intersection. And once again, I used Desmos, went ahead and sketched my graph just so I have a visual image of the system, and went ahead and noted where the points of intersection were at negative 1, negative 4, and at 5, 2. All right, for our last system, we're going to have y equals x squared plus 2x plus 1. There's our quadratic. And then y equals x plus 3/4. There's our linear function. And this time in Desmos, it's looking like there's only 1 point of intersection. Let's kind of zoom in on where it looks like they're intersecting. And again, let's click. And we can see from Desmos, it really is only one solution, only 1 point of intersection at the point negative 1/2, 1/4. And just like with the others, I wanted to make sure that I had a decent visual image to reference in my notes, so I went ahead and sketched it with some of the points that I could see on the graph. For example, I can see the point 1 comma 4. You can see that as well if we zoom out here. There's 1 comma 4. Negative 2, 1 is another point that I can see pretty easily. So just put a couple easy to identify points, make a quick sketch, and then show the point of intersection. So hopefully this has shown you that, with Desmos, it's really easy to graph these equations and find the solution to these systems. Especially because when you think about Desmos here, notice that I didn't change any of the way that we enter the equations. When you think about a TI-84 calculator, you can't plug in some of these equations the way they're written. Like for example, if we look at our first system, x minus y equals 3, you can't do x minus y equals 3 in a TI-84 calculator. You'd have to isolate for y. But with Desmos, you can type in the equations exactly as they appear. You don't have to do any rearranging, and you're still going to get the same, you're going to get the correct graphs. So another reason that I feel that Desmos is just a more powerful graphing calculator than the TI-84 calculator.